All right, we are going to continue solving equations with variables on both sides, but we're going to focus on special cases. Because we have variables on both sides, something happens to the equation. There's not just one answer. Typically, when we solve an equation, we get our variable equals a number. And that happens often. And it's happened every time so far. But when we do have variables on both sides, something special can happen. And those are our special cases. There's two different special cases, but they look very, very similar. When we have the same number of variables on both sides of the equation, our variables subtract out and we're left with a statement. And that statement drives what our answer is. So here's two examples. Let's go through these two examples. They're two different special cases, and then we'll solve. So when we're solving these equations with variables on both sides, most of us won't see that it is a special case until something happens, and something odd happens. So we just need to take our steps from solving equations with variables on both sides and just complete those, and we react to what happens. So the first thing we need to do is simplify both sides of the equation. So for number one, I can simplify this equation. The left-hand side of the equation has a distributive property here. I can distribute 1/2 to 6y and to minus 4. So I'm going to go ahead and do that. 1/2 times 6y is 3y. 1/2 times 4 is 2. So it's 3y minus 2 equals 3y minus 2. And right away, we see that something odd's happening. But we do need to complete one more step. Our next step, because now our both sides of the equation are simplified, our next step is to get all the constants to one side. When we do that, something odd happens. We're going to go ahead and subtract 3y on both sides. Let me do it in a different color here. We're going to subtract 3y. We're going to subtract 3y. And this is one of the reasons why I want us to always get our variable terms to one side first. When we subtract 3y, the y's, our variable terms, go away. There are none left. So we're left with -2 equals -2. We can't do anything else. We're stuck here. Now, what happened? Our variables go away, and we're left with a special case. We need to look at this statement, and this statement tells us our answer because -2 does equal -2. That's a true statement. There are infinitely many solutions. So my answer here is infinitely many solutions. Meaning, no matter what we substitute in for y, our answer is going to equal any number. Any number we choose. We choose 10. We substitute 10 in for y, it'll work. We substitute -30 in for y, it works. It always works. We do not need to check a solution for this special case. So we are currently done with number one. That's infinitely many solutions. Again, the reason why it's infinitely many solutions is because our variables subtracted out and we are left with a true statement, a constant equaling another constant, and that being true. Let's go ahead and look at the second case. Now, this equation looks super complex, but it really isn't after we simplify the equation. There's our equal sign. I put my dotted line down. I'm going to simplify the left-hand side. First thing I need to do is distribute. So I'm going to distribute 5 into the parentheses here. 3x plus 2, I can't do anything yet. I get plus 5x minus 5. And on the right-hand side, I get 8x plus 17. I'm still not done simplifying. I need to go ahead and combine like terms. I have 2x terms and 2 constant terms. I get 8x. 8x minus 3 equals 8x plus 17. Now both sides are simplified. I'm going to go ahead and get all my variable terms to one side by subtracting 8x. When I do that, a special case happens. I get -3 equals 17. Now, this is a false statement. -3 does not equal 17. So we do not have infinitely many solutions. We actually have no solution. And what happens when our variables go away and we're left with a false statement, what that tells us is that no matter what number we substitute in for our variable, it will never work. There's no number that satisfies this equation, so there is no solution. Those are our two special cases. We have infinitely many solutions when we're left with no variables in our equation and a true statement. And when there's no variables and we're left with a false statement, we're left with no solution. Neither need to be checked, and both are complete.